macho picchu and all that.
I'm just thinking, I did that for a job, but I was like searching for jobs.
Where do you live?
I live in North Austin, so I live over like off of Burnett area. Super nice. It's really quiet, which is what I like.
What I did in work was sorting they posted, and it was more than a week.
All right, if y'all don't mind, we're gonna get started. Super great to meet all of y'all. My name is Andres. I've been programming since I was 13, and I run Hispanic Hackers. I also run my own business called Circle Square Labs. We're a full-service technology firm, and then we partner up with Capital Factory to put on events like these for our community. Today's event is going to be about Docker and Kubernetes, which are two of the most popular tools used in technology today. Mostly because it makes running your applications super efficient, very compatible, very, you can send it to a developer, they can run it on Mac, they can run it on Linux, they can run it on whatever platform that they use. And we'll get more into that today, but the whole purpose of today's meeting is to just have an interactive discussion with a couple technical problems on Docker and Kubernetes. So without further ado, our agenda for today, we're going to start by introducing what is containerization and pivot more into how do we apply Docker for containerization. Docker is the most popular tool out there to create containers and container images, but there are other container engines. And then after talking about that, we're going to move into orchestration. What is orchestration? And then what is Kubernetes? And then at the end, feel free to approach me with your resumes, LinkedIn, etc. I like to work as a community to lift each other up. So if you all need your resume revamped or LinkedIn looked at or your portfolio reviewed, feel free to bring it to us. We love looking at portfolios and we just want to see everybody succeed. So let's get started. First and foremost, our sponsors and partners. We're a nonprofit organization based out of Austin, and we're about 10 years going now. The original founder left about 3 years ago, and I took it over then. And then Circle Square Labs is the full-service technology firm that I run, as well as Capital Factory, which is our great host. And yep. So we'll jump into containerization right away. So before we talk about containerization, we should first talk about virtual machines. So what is a virtual machine? A virtual machine is a software-based emulation platform used to emulate a physical computer, right? So it runs its own operating system and applications on top of that. And you can have multiple virtual machines on one physical machine, right? So why we use virtual machines? We use virtual machines to provide layers within our firmware and hardware, so that we can run applications in isolated environments. Virtual machines were used a lot more frequently about 20 years ago before we started coming up with containerization techniques. Each virtual machine includes a full operating system, binaries, libraries, and application code. So you can imagine virtual machines are pretty heavy duty when it comes to the amount of storage requirements and space required to actually keep it. As well as the computing time to run something on a virtual machine. Some key features are they feature full isolation of the operating system and resources. So if you run your program on a virtual machine, you don't have to worry about it bumping into another program or taking up runtime of another program or any kind of resources, because it's evenly distributed across the hypervisor, which is the firmware that allows virtual machines to run on. It's ideal for legacy applications or heavy workloads. They're still featured in a lot of technology today. For example, if you spin up an EC2 instance in AWS, you're basically just reserving space on a virtual machine on one of their cloud computing systems. So this is what a virtual machine looks like. You can see that you have multiple operating systems running off of the hypervisor, which is firmware running on the infrastructure of the actual machine. And each operating system here can have its own, libraries, everything you need to run your program, as well as your application. And this system, although semi-inefficient in today's day, is heavy duty and great because you can tailor your needs specifically on the machine and take up as many resources as you need to, especially when you're using cloud computing instances like EC2. So now that we've talked about virtual machines, we can move into containerization. Containerization is the next generation of how we run programs, both in the cloud and on our computers. Containerization is the process of encapsulating your application so that it all fits into what we call an image. So imagine you take your application and you format it in a way where you can now run it on your computer, you could run it on a cloud server, you can run it on a Windows desktop. You can run it on anything without having to have a lot of changes made to the code. Maybe you might want to add some configurations for specific architectures, but the changes are minimal compared to having to fit your application for a specific operating system. Containerization is great because it's lightweight, portable, and it can run consistently across different environments. It also features isolation from other applications, so anything that you run in a container will be isolated from another container. You can imagine it to be similar to a bunch of shipping containers on a big ship that's on the ocean, right? Everything in those shipping containers are isolated from each other, but they all carry something, and they all have their own compute and storage resources associated with them. Why it's revolutionary? It solves the "it works on my machine" problem. I don't know if y'all have ever had this where you're working with a bunch of devs and somebody's running Windows and he's like, I can't get this thing to work, and you have to troubleshoot it with that developer. It also facilitates microservice architecture, which we'll talk about architecture in a second. So back to our virtual machine model, here you see we have the hypervisor, our firmware, which is on our infrastructure. And then on top of our hypervisor, we have each of our operating systems with our apps. But with containers, you can see that we only have one operating system. That saves a lot of storage and resources needed to actually run. And then on top of that, we have an application or software called a container image, or a container engine. The most common container engine out there is Docker. So if you're looking to get into containerization, I would recommend that that's where you start. On top of our container engine, we have our containers, which are made up of our libraries and resources, as well as our applications. So how does containerization work? Very simply put, you take your application, libraries, and dependencies, and you bundle them together in a very easily formatable way. It runs on any machine, it's very clean, into what we call a container image. And this is usually just a tar file of sorts. And then an example of this would be, a Node.js app that we want to bundle. It has Express in it, which would be your framework, and then we bundle it with the libraries. Then you can run the container on the container runtime or the container engine, for example, Docker. And running the container allows you to share the operating system, as we were looking at here, with minimized overhead. So you're not taking up too many resources, everything is shared and allocated by the Docker engine, and you also aren't having to run multiple operating systems. This results in consistency and efficiency. The same engine can run on a developer's laptop, a test server, or production. And containers use less memory and boot faster than VMs. And that's a big problem in cloud computing, is how much uptime you have and how do you scale quickly. Say you have 5 users jump on all at once and you only have 3 containers running, right? The other 2 containers can spin up a lot quicker than if you were using virtual machines and you only had 3 virtual machines running to handle those workloads, and then you had to spin up 2 other ones, which include, spinning up the operating system and the dependencies. Also, real quick, before we continue, feel free to butt in with any questions you might have, and I just want to make sure that it's okay for flash photography. My friend Diera is over there, and she's taking some great pictures of us. If you have any issues with it, please feel free to raise your hand. I'm not biased, but she'll abstain, so thank y'all. Next, a quick recap on application architecture. I call it a recap because we bring this up a lot in our meetings, because architecture is really fundamental, and it's a fundamental building block on how we build software, and sometimes people just aren't familiar with it. So let's start from the very basics. The very basics, the basic form of architecture is a monolith, right? Imagine you're just deploying your app to a computer, to a machine, and it has all of its dependencies bundled with it. It doesn't connect to the outside world. It's your hello world Python app, right? With the monolith, you might maybe reach out to some external resources, maybe something that's on your hard drive, or maybe something that it'll reach out to an API, but that API is not managed by you, right? It's just your simple bare bones application. Then you have front end, back end. This is an abstraction where we have two programs now that interact with each other through an API. The front end, back end model is great because the back end provides a level of security and privacy. So as long as you're controlling what goes into the back end and what comes out of the back end, you can trust that what happens inside of the back end is not exposed, as long as, again, you set up the security repository and all of that the appropriate way so that it's private. But this abstraction means that the user sees everything on the front end, right? You can hack into the front end and change it. But the back end, that's immutable as long as you provide the right security. So that's why I usually use the front end, back end systems. The back end does all the user management, contacts all the APIs, etc. typically. Next we have containerized. So that's what we're talking about today. We're talking about Docker and containers. A containerized application puts a layer of a container around the server, or the backend in this case, and we can run this container in parallel with multiple containers on one machine. And the nice thing about this is that it provides, that compatibility. You can send it to anybody. It makes it easy to switch out a container if you need to, and change it, modify it, and redeploy. And it makes it more efficient when you're running it in the long term.
Cool question. Regarding the containers, because of the way that they have a shared OS, do you have to deploy different containers per operating system, or
not necessarily? You have to reformat. Sometimes you have to tweak it per operating system, especially if, for example, if you're trying to access content that's on the operating system. For example, having like persistent storage, right? And we'll talk more about why that becomes an issue in the long run. But in terms of us actually having to reformat the container, it'll run smoothly on any Docker engine that exists on any operating system, as long as, again, you're not trying to use the operating system's resources, right? So really, imagine that container being like an egg, right? And inside you have your yolk and the bread and butter of what makes your application, but that egg puts it in a uniform environment where you really don't have to rely on anything from the outside. It seals it up, right? So containers are really great for that reason. They can be easily exchangeable, they can be easily updated, and they are super compatible for whatever machine you want to run on. That's part of why it's become semi-standard to use containers in industry. Does that answer your question?
Yeah.
So the last but not least architecture that we're going to be talking about today is microservice. Microservices are where you break down your application into multiple small containerized applications. So this could be when you're processing, for example, like payments, right? You might want to have a container specifically for processing the payment, keeping it isolated from the rest of the components in your application, as well as maybe another container that is created to manage users, user data, and user state. And then maybe you have another container that actually runs, for example, you could have like a contacting service or something along those lines. So breaking down your application into multiple containers can be a really useful skill and strategy. And that comes into play with bigger companies especially, because what they'll do is, that a guy who works at Apple doesn't work on every single product, right? Or every single feature. Somebody who works at Apple would work on maybe just the contact app, or maybe just the Safari app. And those apps interact with each other. So each team is dedicated to updating a certain code base, and that code base is linked to a certain container usually. So containers allow you to be able to switch in and out the code that you're using and update the repository without having to update every repository, and then you link them together using networking or APIs, right? And so a microservice model allows us to be able to exchange our containers efficiently and update them as well as keep them isolated from each other. And then finally, we have a serverless model. So serverless model is an abstraction of our microservice model. It's where, and this applies when you're using cloud services, it's when you deploy in a serverless format, meaning that your code doesn't have a dedicated server. A lot of times this just means you drag and drop your code to your cloud provider, and the cloud provider will manage spinning up the code when it's needed. So because it doesn't have a dedicated server, it's considered more efficient. It's considered a little bit cleaner and easier to manage. And as a company or as an individual, you don't have to manage it yourself, whether it's going to be scalable or the amount of runtime it needs, right? The resources are all managed by the company. And so serverless models are really great. What the serverless model does in the back end is when you drop your code in, AWS or whatever cloud provider you use will go ahead and containerize your app for you and then deploy it in that instance so that it's modular and reusable. So another benefit of serverless is that a lot of cloud services are provided already in container format, and through using a serverless cloud model, you can connect your services across your cloud ecosystem and be able to have direct access to some other cloud services that aren't just your maybe compute or runtime, right? So you can connect your app to a database that's already in the cloud ecosystem. You can easily connect it to authentication, or you can easily connect it to other modular serverless functions. And so serverless, the serverless model can be really efficient. I highly recommend it if you don't require persistent logging, because serverless applications are stateless, meaning that whenever you contact it with an API, it'll run, but it doesn't keep any persistent context of what ran last. So for example, if we were running an app that was a quiz app, right? And the quiz app is tallying points throughout the whole entire time that it's running, you wouldn't want to use a serverless model because every time you send data to it, it's going to take that data and then it's going to forget it. So for that instance, you would want a microservice or a containerized environment that is purely running all the time so that it's continuously running while the user's using it. So if you send an API request and say, hey, add another point, hey, add another point, or this is my answer, this is my answer, this is my answer, it can keep track and it'll stay active until the user logs off or until the user terminates the session, right? So containerization in general is just a format of containerizing or really packaging your application. Applications typically do run and have state as long as they're running. So with containerization, you could have multiple images or multiple services running at once, and as long as they're running, they're going to maintain their state. However, the one drawback of serverless is that the serverless model is hit and run, right? Hit and go. So every time you contact it, it's going to lose context of the state because it's only for very modular, very singular applications.
That means that all things that you're sending, you don't have access to any bits. That's just all in RAM, right?
Yeah,
Okay.
exactly. It's all in RAM. And so a way to solve that problem is you could update maybe a database and then reach back out to the database for that data to be able to provide persistent storage. But you would have to really make an effort to maintain persistent storage. And so that's why serverless models can have its drawbacks. The benefit of that is that your compute instance isn't running the whole time, right? You don't have it running 24/7, so it saves you a ton of money. Because hypothetically, you deploy an application that's either on a virtual machine or containerized, that application is going to have to run 24/7 to make sure that it's available when somebody contacts it or somebody needs it. So now we finally get into the technical problems. If you brought paper or pencil, or you have your computer with you and can use draw.io or something along those lines, these first two technical problems are going to be architecture problems. So we've talked about 3 different architecture types. If you have any questions, I can definitely go back and reference them. Also, if y'all would like to actually come up here and draw on the whiteboards, we have the whiteboards as well for y'all. The first technical problem is to imagine that you are building a Uber-like application. It could include rider registration, driver registration, trip requests, and real-time persistent tracking and payment processing. So those are 5 different modules already, right? 5 different components to the problem. Each part of the application will be managed by a different team and will share a database. So for this problem, the question is, what kind of architecture would you use for this app? What would that app look like in terms of a architecture diagram? So I can go ahead and show you all what an architecture diagram looks like from what I've built. I don't actually know where I kept it. And then finally, how would the data flow throughout the application? So I'm going to set y'all loose on this. Y'all will have, let's say, 25 minutes to come up with a general sketch of what the application would look like.
Can you list the 5 again?
Yeah, yes, it's up here. Here, let me this back. It will include rider registration, right? So you have to register to ride. Driver registration, trip requests, real-time persistent tracking, and payment processing. Now, 25 minutes is not a lot of time, so feel free to do your best, and then we'll talk about it, and we'll see what everybody comes up with. If y'all would like me to show any specific architecture, feel free. When I talk about architecture diagrams, that typically has to do with block diagrams, right? So imagine that you are symbolizing each one of your components with a block. For example, we might have rider registration here, and this would contact the database and store data for the rider, right? So the database in of itself would be its own service, and then rider registration might be a service, right? So go ahead and experiment, figure out just what would that architecture look like, what would the app look like, and then how would the data flow between all the components. And if I'm going to go ahead and look for a item here just to show y'all what some architecture diagrams that I've found helpful. Perhaps actually better. Just hold up here. Here's an example of architecture diagram that I have done. So this was for a email messaging service where I was using AWS SES. And so here you see we have AWS SES. Here we have SNS, and they're connected. These are cloud services. You don't have to get in so much into the technical details if you aren't familiar with cloud services. But here you can see I have my application, and inside of the application I have some level of logic showing where things are flowing. And you can see this is the data that's going to be sent to SES, and some other components in here, like a database. So do your best. If you have any questions, feel free to ask. Happy to answer, and then we'll talk about it after.
Back to the...
Yes. Not a problem. Would anybody like to use the whiteboard? All good? Okay, cool. What I like to use for my drafting of architecture diagrams is draw.io. It's a really great free program on the internet, and it's draw.io.
Draw.
Yeah, and super helpful. So feel free to ask any questions if y'all have them. I'm going to put on my timer. We'll touch base in 25 minutes. If y'all need to use the restroom, they are to the left, right, through the main hall, and then to the left and the right again are the 2 restrooms. So they'll be on either side over there. And then there's water outside as well.
So what was the third point? The real-time persistent.
Real-time persistent tracking.
So what does that mean?
So, for example, when you get in an Uber, you're going to be tracked while you're moving, right? And the driver is also going to be tracked. So, having that real-time live
Okay, when
persistent
the
feedback.
trip is active, that's when.
Yeah, yeah. So it's when you're actually active on a trip.
I was free form. It's a big deal. It should be on the. Yeah.
For the internet, are we connecting to the Omni lobby?
There should be an Omni guest.
Omni guest.
Yeah. More than happy to help if you can't find it.
And then, what number are we entering?
For the Omni guest?
Yes.
Oh. You should. Oh, you know what?
I use the
It should be capital factory, yes, that's what it is, yeah, sorry, my bad.
No problem.
Yeah, capital factory, yes. Forget that we're, capital factory is pretty wrong. So, however you, like, it's up to you. 25 minutes is not a lot of time, so whatever you feel like you can accomplish and feel good about. This is by far the longest problem that we'll have today, so. once you feel settled with this technical problem, we have 15 minutes left, feel free to move on to the second one, which is a little bit different. Just to kind of piece it together, but if you don't get to that point, no stress. Good.
how about the read functionality? Like more reads than writes, or basically just more uploads?
That's a good question. So, in the case of the second technical problem, you would just be uploading to the cloud. But if you wanted to actually read from the cloud, then maybe you had another service there, right, to contact the S3 or the storage service, right? But this is just simply, what if we were just polling like traffic cameras and storing the license plates of different cars, right? Yeah. And we're about time. It's about, we have 8 seconds left. So we're gonna go ahead and move on. Is anybody up to describe their solution to technical problem number 1? Would anybody like to go?
I think first off, it's really important to actually segregate a couple of things. First off, you want to segregate the authentication stuff, so that we all the writer database, driver database, and stuff into its own little system, like an authenticator, so it could be its own microservice on the side.
Yep.
So usually what that's done is like you send credentials, like username and password to that one, and it gives you back a bearer token. And that bearer token is what you use to go to the other databases, which would be the write tracking one and the payment processing one.
Yep.
And so for those are each be their own microservices, whereas the write tracking is basically just keeping the time series database for the driver and the writers, meaning that it just kind of pulls every single GPS point that you send to it and holds it, and then from there you can just process the stuff that's coming out there. The third one would be like the transaction, the payment processing stuff. So you really do not want that to be close with any user identified information, so that's got to be its own microservices.
Yep.
So for that, you'll just probably also, you'll send it the bearer token and stuff, so it can actually tell you like keeping track as far as like the payment types for that bearer token and stuff. But you don't want user identified stuff with that to be able to use that to just get the requested data back from that. So those 3 microservices are usually probably, you want it to go behind a reverse proxy. So for those of you that don't know what a reverse proxy is, it's like, if I say I'll go to example.com/payment or example.com/transaction databases, that means the reverse proxy allows it to have that kind of URL without those actually being on the same machine. So with the reverse proxy, you're able to, the proxy itself will manage any traffic, so they'll do things just like partitioning a lot of the different servers for one item or stuff like that. So it's actually, the reverse proxy will know the actual computer URLs for each one of those, but the actual user will just communicate with the reverse proxy, and that also helps with the traffic stuff. And of course, the reverse proxy then goes down to the app, and if you use your APIs and stuff, then do it that way.
Yeah, nice. That's a great explanation. I can go ahead and show the diagram that I came up with, which is very basic, but there we go. So, like Ramiro broke it down, he said, we have multiple microservices broken down for each task, right? The nice thing is that a team can manage each microservice. Something that I did here, and I also did for the second problem, was I used kind of a hybrid architecture, where for user registration and returning user data, you really just need to contact it once. It doesn't really need to have persistent state other than what's in the database, right? Because it doesn't need a long-term persistent contact. You just have to contact it once. It'll go ahead and send to the database. You can contact it again, and it can from a different route, and you'll receive from the database, right? And like Ramiro was saying, you can use a reverse proxy to be able to combine all of your routes together and contact different services, right? So here we would use serverless for just sending in registration data and retrieving registration data, potentially, right? Then for payment processing, you definitely want that isolated, and for that you need some kind of persistence, because have y'all ever been on like Eventbrite and it'll say you have 20 minutes to check out or else you lose your ticket, right? With all kinds of payment processing, it takes time, and the payment authorizer has to actually be connected to your app, and because of that, you're having to wait on multiple background items, right? So for that, serverless model isn't so great because it's needs some level of persistence that's not just, hey, let me store data, let me retrieve data, right? So for that, you would use a container. So you use a containerized service here. For payment processing, if you're just building your own app, you can use a service provider like Twilio. Twilio? I think Twilio. No, Twilio does SMS. There's a couple of them. Stripe, that's the one I'm thinking of. And they have it already packaged for you, so you just contact an API. But in this case, you can also create your own payment service by setting it up with a payment provider like Visa or Amex, etc. So you would have your own container for that, and then you'd also have a container for real-time tracking that would manage and pull the constant location that would be sent from the front end or from the user's machine, right? And then triaging that with multiple phones. Maybe you have a specific route that you're sending to, and you've already coordinated it with both phones, right? And then the last thing that I added here was logging. That's always a great addition. I'm a big fan of the concept of observability for first. When you're creating an application, make it so that you can observe the outputs and the outcomes of the app, so that you're not just left in the dark, right? So that you know that your application is running smoothly, and it's also, you know what's going on, the processes that are happening, and how much compute and runtime you're actually using as well. So that was the brief on the solution for this. There's no one solution. What Ramiro said was great and very in-depth. So that was fantastic. For the second technical problem, the second technical problem would be used, for example, traffic cam surveillance, right? Imagine you're driving down the road and there's a camera that's taking pictures of everybody's license plates, and it's running it through the police database to check whether or not that license plate is maybe flagged for something that the police need, right? So for that, you're going to need to make sure that the image is of the correct size. Then you're going to want to use AI service or a AI photo recognition service that will narrow down the characters on the license plate. We'll be able to identify, hey, that's a license plate, and then tag it with the license plate number, right? So converting that content into text. That's called optical character recognition, or OCR. So you'd have an AI service doing that. And then finally, watermarking it maybe, so maybe highlighting where, putting a box around where the license plate is on the image before uploading it to a database or a storage service. So that's what this technical problem is. The model I had created real quick for that one looks a lot like this. So you have your front end. Again, this could just be your ingestion, which would be the camera, right? That would send the image to a serverless module for resizing the image. Because again, it doesn't really require any level of persistence. It's just sending it over, reformatting, and pushing that over to the next microservice or next serverless function. The next function will go ahead and contact an AI service, and then as soon as that AI service returns the tag associated with it, for example, the license plate number, it'll go ahead and log that tag, right? Maybe it writes it into the name of the photo. And that's a really great way to maintain tags, that it just writes whatever it receives into the name of the photo. Or maybe it gets stored via AWS into a separate text document, right? But finally, you can either optionally watermark it if that's been checked off by the user, or you can go ahead and send it directly to a service that will store it. AWS S3, we've talked about this in our cloud computing sessions, where we've talked about that, is just a service that holds media data, right? So imagine you want to store images or videos or text files. That would all be going through S3. Instead of having to store, break it down into data formats that would be stored in a database, or break it down into some level of like a JSON object model, which would be in a non-relational database. So this is a general solution. Again, all of these are very open-ended problems, but these are problems that you're going to see in technical interviews, and most of y'all have probably seen before. A lot of times when you go into a technical interview, they want to see how you solve the problem, not just how well you code it. So always helpful to run through these. Okay, so we're going to take a 5-minute break. Feel free to go get water, go use the restroom, talk and chat. And we'll come back at 8:03 and move on with the rest of the presentation where we actually jump into Docker and how we manage our containers with Docker, Kubernetes, and etc. So yeah. Pedro, where in the Dominican Republic did you visit?
Santo Domingo.
Santo Domingo. That's where you're from, correct?
Yeah. I also went to Puerto Plata.
Ah, it's so nice.
And Rio San Juan. I don't know if you know Samaná.
Yeah, Samaná. Isn't that right over by Los Artistas?
Yeah, after Los Artistas, yeah.
Yeah, it's so pretty. I need to go back. It's been like 5 or 6 years. I was really little the last time I went.
Oh, wow.
Well, not little, really little, but like I was in high school. So it's been a while. It's so beautiful out there.
Yeah.
I also think it would be a lot of fun out.
Do you constantly like refresh your data sessions at all? Or actually, like if they were let's say, are you constantly refreshing that? Yeah.
So you work here?
No, so I run my own firm, but I actually just landed a long-term job, which is nice. But I work out at the co-working center. They give us a free membership as like the people who are organizing and running Hispanic hackers. And then I do work for Hispanic hackers as the president. But we don't try to generate revenue. We're more there as a structure for providing opportunities for community.
So are you actually like an incorporated entity or? Alright, so 501c3.
Yep.
Alright.
Yeah. I actually established it as a 501c3 because I wanted to be able to open the doors to opportunity and also be able to, declare us as like a formal brand. But we've been running for 10 years. It's fantastic to see how many people like come through and then how many like recurring faces we have. It's really great.
It's good stuff. I'm surprised there's not more people.
Yeah, it's hard because we're downtown and we're right after work on Monday, right? And like on Mondays, a lot of times I just want to go home, So I get it. And then also people never know where to park. That's always a concern for people. Even though parking is free on Mondays and Tuesdays, there's not a lot of people.
Yeah, street signs.
Yes.
It's right out there.
But we usually get about half of the turnout, right? Like 36 people RSVP'd, and I think I counted 12 to 14 people who are actually here.
So this area right here is co-op?
It's a co-working spot. So beautiful view. They stock it with snacks. You can reserve a desk, or you could just pay for the membership and co-work amongst everybody else. Sweet.
So So it's like a country club for programmers.
Yeah, basically, it's a lot of it is entrepreneurs or people who are trying to start their own company. It's great to network. There are a lot of events like this that run out of it. And then a lot of companies that are just really small and they don't want to reserve office space, so they just share with everybody else. Imagine it as like Google if Google was broken up into a bunch of different little businesses.
No, I understand.
It's pretty cool.
Airbnb for office space.
Yeah. There are different co-working zones all over the world. I mean, I've been to some in like Chiang Mai in Thailand, or in Tokyo, or in Mexico City. They're everywhere. So you don't have to look far, but this is a really particularly good one because they set you up with connections and networks. So it's a little bit more niche versus some co-working spaces that are just if you don't want to work from home. Right?
I noticed that there's an emphasis, maybe just the way the organization operates, but personally I'm very focused on utilizing my own hardware.
Yeah.
So this is all very foreign to me.
I gotcha.
But I mean, it's fine.
Yeah, it's new concepts. What's your question?
So the design that we looked at, from container point of view, where did we use containers and where we didn't use containers, basically?
You're allowed to.
Great question.
Containerization.
So to elaborate a little bit on that,
People that have like server
here
farms
the
and stuff,
blue
they're
would be
actually scalable,
containers
so it actually makes us a lot
and
more
green would be
easier across
serverless.
things.
So I didn't explain that well enough, my apologies. But blue refers more to, this is a container that's going to be running and up, so that you have persistent runtime. And then the serverless are just atomic, I need this process done, and it's like you're running a function, right? Versus running a whole program.
What is the presentation layer? Which one?
Ah.
The presentation.
The front end would be the presentation layer, so this would be your React app or your.
Which one? Resize, diving, embedded, or
It'll be front end.
Front end.
Oh, no.
Front end is your presentation.
Well, we have 3 layers.
Mhm.
Presentation layers, domain layers, and database layers.
Domain layers and what else?
Database.
Database, yes. So,
I mean, in microservices, if you don't have to design what is the inner style, we started is for the presentation layer. But before they decide which pattern we have to follow with the domain layer, because it's in the middle.
okay.
It's backend.
Yeah.
Presentation is
With
the front
the
end
front end,
where,
yeah.
okay. But in backend is, in that one, for me a little confusing because I never worked with it. I know what has to be in the domain layer.
Yeah.
The database layer is just pull out information.
Yes.
It's just only. And in this case, AWS, if you build the app, you have to go aligned with their requirements because this is cloud.
Yes, yeah,
In cloud, they have a particular,
yes.
they have their own requirements.
Yep. Yep.
In Azure, in Google, they are completely different, the requirements. This app will be interact with them, or how you will use this app?
Good question. So here, the front end, that's your presentation layer, right? And then these would be your domain layer. So the front end would just be, let's say we're deploying a React app on Vercel, right? So in terms of the presentation layer, that's what it is. It would be a React application on Vercel. So you program out the whole front end separate from the rest of the microservices or the serverless.
Okay. This app is independent, the cloud, because you have an app here. Okay, I bring my app to their server.
Yeah.
I deploy.
Yeah.
Okay. Now, this app is independent, or this is in Amazon already in their servers.
This.
It will be independent. You
Yes.
will be integrated with them. It's only
So yeah. So and that's a great point. What we would have is we would have a AWS layer, right? Our domain and database layers
Sami,
would be all contained by this right here. This would be what would be on cloud services on AWS, for example.
okay, it will be held in their servers.
Yes. So
So I mean, nothing, I build my app,
Mhm.
then I work with them, integrate with them.
Yes.
I don't know if they allow, I don't know, I've been in cloud, right?
Yeah.
In those cloud. But, they have already, only what you have to know from your premise, send it to, or deploy to their servers.
Yeah.
Or they have different
Yeah.
fees. Anyway, but I don't know, for this new, if I build my application, if they allow me integrate with them. This is for me the question, because this application it's yours, you will integrate with them?
Yeah, that's a great question. So, and that makes sense. So one thing to note about serverless, which the green are serverless, they run as functions, right? And so when you're uploading your code to say AWS Lambda, which is their serverless service that they offer, there are size requirements. So that's part of why we can't have a whole AI recognition service as a serverless item. Because AI takes up typically a lot of space, and it typically requires more compute time than what serverless can allow, right? So instead, we use modular functions for the things that we can process in small format. And that allows us to have compatibility with their serverless services.
Your application will be in your premise. You will deploy in their service.
Yes. What could be on premise would be the front end, right? But everything else would be in the cloud.
This is your application.
Mm-hmm.
Then I Docker, you made the containers in Mac. I bring this one. I put here. This is what we are doing with the application when you deploy to AWS, their servers.
Yeah.
Now, when this is in their server, they hold it there. Now, you interact with them, your own application, because it's already there, or you put them if they are managed.
That's a good question too. So with serverless, they would typically manage how your application gets deployed, right? So you hook up your serverless, in this case, to what we call an API gateway. I had shown it previously and very briefly in our model here. Here there's a gateway, right? The gateway just manages internal server traffic. So AWS is really great. Lambda, their serverless product, allows you to connect it to multiple different triggers, right? One of the triggers is an API request. So in the case of our image application here, we would send an API request. We would send an API request to our backend ecosystem. Our backend ecosystem is just all of our different serverless or containerized applications that are on the cloud, right? So we'd send it to our API gateway, which you can imagine is right here, and then from that API gateway, it's going to send it to our serverless function. Our first one is just to resize the image. So that's going to go ahead and resize the image. Of course, we have to meet the standards of AWS for our application, our program that we're sending to this function. Yes?
So do we still need to take care of any queues that may be required in between?
No, you wouldn't have to have any queues for, like, say you have multiple requests, right? Multiple
Because
images.
resizing image, it might take time.
Yep. And so that is all done with the load balancer, and AWS manages that as well. AWS provides another service called Elastic Load Balancer, which allows you to balance out the number of requests coming into your application. But AWS provides that all for free and automatically. You don't have to configure too much when you're creating a API gateway input driven serverless model. So that's another service that they do provide. We haven't jumped so much into the cloud services. We're mainly talking about containerization today, but there's a whole other layer, and we talk about this in a lot of our lessons about cloud computing. When you get to AWS, it's just immense. Same thing with Azure and with Google Cloud.
Regardless, let's do specifically Docker. What Docker does?
Yes.
Okay. When you have your application here, here's my application. Then I want this bring into cloud. In this case, AWS. So what I do is create a image in my application here.
Mm-hmm.
I deploy it to their servers.
Yes.
Then this is a image, it's like a file. You have a code, you stay there. Every time when you want deploy a stream to local, because you bring a stream,
Yeah.
you use the Docker, the file. It's a file. You
Yeah.
make a file that your application.
Yes.
Send it to them. This is a good way, say very safe,
Mm.
but at the same time, as you have to keep really close eye in your image, because Docker has images, a lot of images in there,
Yeah.
and their servers. I worked it before.
Yeah.
I deployed it before. So if you use AWS, it's super easy. The
Yeah.
abstraction is, they are very helpful.
Yeah. They have
The
lots of
abstraction
documentation.
is-
And, yeah.
No, you bring to here to local, from
Yeah.
there to them. Use scripts, copy-paste scripts.
Yeah. They give you a lot of
But
resources.
that's you have to have sign a account, you pay for each time. But there is a way how you save money to do that.
To prototype on your computer?
It's just as a strategy.
Yeah.
You don't have to use their servers all the time.
Yeah, and so you can do that in multiple ways, right? With you can use Kubernetes instead of using their cloud cloud formation.
No, yeah, Kubernetes. Yeah,
Yes.
but they have already the abstraction for the EKS
Yeah.
in Amazon.
Yeah,
They already have it there.
yeah,
If you use Kubernetes, the framework in your application, in your systems. Or, Kubernetes has bare metal, hybrid, private.
yeah. There's a lot of different.
No.
approaches.
This is bare metal is the more difficult. Private, public, and hybrid.
Yeah,
I don't know which one the companies here, which one more use with kind of abstraction they use.
yeah. We'll get into Kubernetes in a sec, but you're right. There are different abstractions of Kubernetes, and really the use case depends on it depends on the use case which ones you choose, right? But let's jump into Docker. So what is Docker? Docker is an open source platform for containerizing your applications and turning them into images, right? And we've talked about images. They are just a packaged way to package your libraries, dependencies, and your application together. How does it work? Applications and their dependencies are packaged into an image. These images are executed as what we call containers. So imagine an image is like a flat version of a cardboard box, and then you fold it into a container. That's just, well, it's a similar concept, and so when we run a container, we call it spinning up the container. So you spin up a container or you spin down a container. Spinning down means to stop the container. Containers share the host operating system, making them faster and more efficient than virtual machines. So why we use Docker? We use Docker for streamlined development and testing, simplified deployment across environments, and enabling microservice architecture. So some core components. you'll hear me talk about the Docker engine. That's basically the runtime responsible for actually building your applications. It handles all of the nitty-gritty in the background for managing the resources needed on the machine. Then you have Docker images. These are your read-only templates or your read-only code. That is the compiled version of your code, dependencies, etc. Then you have Docker containers. This is the running version of your Docker image. It's when you actually are running your container. Docker Hub, and something we had just mentioned, is where do you store your images? You send them, of course, to a cloud service provider, but cloud service providers like AWS have their own container registries. Registries are where they're just like GitHub, where you have a repository, but instead of holding raw code, it holds containers. So the equivalent for AWS is AWS Elastic Container Storage, so ECS. And then Google also has container storage, and so does Azure. Docker Hub is a open source container storage application that's cloud run, and you can use it through Docker's system and ecosystem. And then finally, Docker has a CLI, so that's how you run your applications through the command line interface. Why use Docker? It integrates with orchestration tools like Kubernetes seamlessly, and it also has a really large ecosystem. So you're not having to worry about, community involvement being too little or not having answers to questions. Usually it's well documented, there's a lot of support, and there's also a lot of tools available for you to accomplish what you want. So the way this all plays out, we were talking about how we make images. Essentially, we take our source code, maybe framework and libraries. We take our library files here and we add in a Docker file to the root of our directory or the root of our project. What a Docker file is a Docker file is the set of commands that the Docker container uses to install any external dependencies and set up what that Docker container is going to do, right? So it does all the same things that you do when you're setting up your project for the first time. You go ahead and create your, for example, your package.json if you're using Node.js, or if you're using Python, it's a requirements.txt file that lists the dependencies, right? So you get that, then you go, if you're using Node, you'll do npm install with your package.json, or for Python, you go ahead and install the dependencies in that requirements file, and then you're going to go ahead and run npm start. For like Django, you run another set of commands to run the actual Python app. So essentially, what the Docker file is it's just a set, it's kind of almost like a bash script saying this is how we set up the project. It's not exactly in bash language, it has its own language or its own set of commands for setting it up, but it gives the instructions for how we turn our image into a container. So containerization is just us converting it into a tar file. You can compress it and then ship that off to a container registry. So the container registry is our cloud provider that holds our container in the cloud. Then, from our container registry, you can run the image on any machine. You can either download it locally and run it and spin it up using the Docker image on your local computer, or you can coordinate with a cloud service provider to run it in the cloud from your Docker registry or your container registry. When you spin it up or run it, it will turn into a container, and the container runtime, or Docker engine in this case, will go ahead and manage the resources needed and the compute time needed for your application. All of this can exist on a single operating system, which makes it very efficient, and you can have multiple containers in parallel on one system, with them all having isolated code. And the nice thing is, say we need to update our container, all you have to do is update the code inside your container, push it to your container registry, and it will replace the image in your container registry, and then you can spin up the updated version of your container. So some benefits of containerization are portability. You can use it on any machine. Efficiency, and we've talked about that. Rapid deployment, that's just meaning that it spins up a lot quicker than a virtual machine would. Then scalability, you can scale it horizontally by spinning up more container instances. And isolation, which means that we're keeping our code separate from other code. Some challenges would be resource management and scaling. And the more complex it gets, the more you're competing for resources. So if you're running too many containers on one machine, you can see poor performance. That's part of why I say I'm a big believer in observability first, because you want to know how your applications are running and how much runtime they require, as well as how well your programs are performing on your cloud service or just on your machine in general. Networking complexity, if you have a microservice environment, you have to coordinate between all the microservices to send data across each other. It can get to be a hassle, but it's more or less like coordinating API requests. Data persistence, monitoring, and debugging. This is possibly the greatest issue, is persistence, right? Whenever you shut down a container, the container dies. So the image persists, but the actual container doesn't hold any data, because all you do is you're shutting off and deleting that container instance. So then the next time you spin up an image, it doesn't have any recollection of previous container instances. So to be able to persist storage and data, you have to set up a database that the container can reach out to, or you can set up volumes or storage that are on the actual machine that the containers are running on, that it will store the data on and be able to retrieve data from. So that's how you network persistence. We'll talk about data persistence in a sec. And then finally, security concerns. Sharing an operating system and sharing operating system kernels between containers can introduce vulnerabilities if security is not properly managed. And so some solutions to this are using namespaces, C groups, and imaging scanning to be able to check out whether you have any vulnerabilities in your app, as well as being able to securely network between your microservices or multiple containers, especially if you're exposing it outwards. Does anybody have any questions so far? All good?
One question.
Yeah.
Can you please go to the previous?
Yeah.
Where the image was?
Right here?
Oh, yeah. So in the Docker container image, the Docker file contains a list of basically it's a script.
Yeah, it's a script.
But the libraries and framework, is it pre-populated or is it part of the Docker file?
That's
just commands.
Usually the libraries and framework are what you install into your app, right? So you'll have a directory that says, this is my app, and this is my source, right? You'll have your source directory, and in there you'll have your app, your framework, your libraries, you'll have maybe React running. Or, well, in this case, because it's a container, you most likely have like Node.js running, right?
No, so my question is the Docker file causing all this to be populated, or is that already included?
So the Docker file will populate maybe some of the resources internally, but it will mainly take from your source code, framework, and library. So if you need anything external, you can organize that in the Docker file. Does that make sense?
So your Docker file has you would list what all softwares you want.
Oh, that already is.
The Docker Compose, you will tell what services you want.
Okay.
Yeah. So the Docker file is just, and we'll look into the Docker file right now. The Docker file basically sets up the basis for how our application is going to get created, right? So we start off with a base image. This base image here, we're using Node.js, and we're using the 20 Slim version. This basically says we are creating an image that takes after another image that already exists. So this base image is the very basis of what runtime we're going to use. So for example, if you're running a Python Docker container, it's going to have a different image than this one, which uses Node.js, because it's using a different runtime. So the base image is determined by the runtime as well as your running requirements, right? So your compute requirements. This is the 20 Slim, which 20 is the version, and Slim means that it's a smaller image than maybe other versions out there. Now here, we are downloading some common dependencies. We are downloading, imagine that your Docker allows you to run tools in the container like it's its own operating system, right? So here we're going ahead and using apt-get to get a couple different libraries and tools that we'll use in our container. This Docker file specifically came from a project where I was doing data scraping. So I was using Puppeteer and Chromium to be able to data scrape, and because of that, the container needed to download Chromium and all of Chromium's respective libraries. Chromium's just a version of Chrome used for data scraping. And so because of that, we had to go ahead and install all the dependencies. This isn't Node.js dependencies, but these are more common dependencies that are going to exist within the environment, right? Next, here we have we're checking if the target architecture is equal to ARM64. If it is, it'll go ahead and download this version of Chromium. And if it's not, then that's handled in another step. So that's part of why you can see here, the only reason I'm showing y'all this complexity is that I'm showing that there are possibilities of adding, if-else statements, conditionals, or other content in your Docker file, in the Docker file lingo, which is well documented by Docker for whatever you need in your application. It's very flexible. Next here, we're setting up some environment variables. We're setting up where our working directory is going to exist. So where are we actually going to populate our source code is our working directory here. So that's kind of like your cd command on Unix or Linux, where basically you are changing into that directory and that becomes your directory reference, right? And then here we're copying our package.json file into the root, which is user source app. Finally, we are going to go ahead and install using npm our package.json dependencies. So that will go ahead and install all the libraries that are referenced in package.json onto the computer. The reason here for the conditional checking target architecture is that before I install my dependencies, I want to set this environment variable if I'm on ARM64. And again, this just has to do with architecture and what architecture it's running on. Because we're running an external dependency that isn't in Node, but is instead more of an application that we're installing into our application, right? Because we're installing Chromium as a whole, and we're bringing it into our container as though our container is our entire runtime, our entire environment. So it does have to do with architecture to some extent, but that's because we're bringing stuff in externally that's going to have to live in our environment. So you can see here we're actually filtering out by architecture what actions we are and aren't doing. So that's where the configuration can get a little intense, but it only gets that intense if you're moving outside of Node and you're trying to also bring in other dependencies that are applications inside of your application ecosystem. Finally, we're going to copy all of the files from our repository, or all of our source files, into our application, because now we've installed our dependencies, now we've copied in our code, and finally we're going to expose port 3000. That means that if we want to contact this container and run a route on this container, we would be going to port 3000 on our host machine. And then finally, by default, we'd be exposing 3000. But it also is exposed internally. And we'll talk more about that when we get to Docker Compose. Finally, here we're setting some more environment variables, and then we're starting the app using npm start. So this is a lot more complicated than it needs to be for y'all, but I wanted to show that you can have a good amount of complexity in your Docker file to set up any variety of apps, including apps that require external applications or external binaries that need to be pulled in. Chromium, for example, is a binary.
Yeah, cool question. If you go to the slide beforehand, the common dependencies, those are definitely,
Yes.
This block is completely Linux, particularly Debian.
Yes.
If you were, and I know the Linux is definitely the most common thing that they use on the servers, but let's say you ran into you were using a service that uses like Windows servers, for example. This would have to change to be installing that, right? Or
Yes.
Okay.
So that's it, right? If your platform was different, if you were using a different architecture, you might have to have an if a conditional here saying, if this is Windows, install this set of dependencies. If not, set these dependencies. But I believe that running Linux style commands applies to every architecture when you're using Docker containers. Docker by default uses a Linux style in commands.
Oh, sorry.
But yeah, that does that.
The common portion that you mentioned, it's still contained for the container, right? That particular Docker. It's not common across anything else.
Yes, it only pertains to the Docker container. So
But other apps running in that,
are there any?
they can use, like Chromium, if it needs, it can use.
It only belongs in the container, so it
Yeah.
can't be used by any other containers, which is great, right? The reason why we set our base image here is because this base image comes already with Node.js runtime installed. It's not that the image itself is the runtime, but the image is like a version of your operating system in a small package that contains the runtime on it. Does that make sense? It becomes the basis where we build our app on top. So this brings us to a third technical problem. And this technical problem is asking to write a Docker file that meets the following conditions. And we're going to do this one together, A, for speed, and B, because this can be a little bit complicated with some of the past examples, right? But it should be a very straightforward approach. So the first thing to write our Docker file is we want to use Node.js. We're using the Node.js, this LTS, it's long-term long-term support, that's it, yeah. Long-term support base image. So we're basically installing the long-term support version of Node.js, and this is using the Node 18 Alpine image. There are different companies that publish different base images. So for example, this one's run and managed by Alpine. So to start it, we're going to use
The problem
oh yeah. Here, to start, we're going to declare from, and then we're going to declare our base image, which is Node 18 Alpine. And this is a very basic base image, right? You might have noticed that here in our more complicated format, we are declaring the build platform. This is coming from an environment variable, and that's just an extra piece where we're trying to specify the build platform so that we can narrow down which specific version of our base image we're running on. But that's because this application has to be ready for production deployment as well as local deployment. Versus if you're just deploying locally, you can use very simple jargon here, very simple notation of just from base image. Now next, we want to set our working directory at user source app. So we're going to go ahead and run this work directory command next, which is going to be work dir, and we are setting it to user source app. So this is where our app is going to live. And I believe that if app isn't already created in the container, it will create the directory for you. So this basically creates an app directory that is within our user source directory, which comes pre-built into the image already. So that's again one of the benefits of having a different image. Is different image gives you a different base to start from, right? A different base image is just that, the base. And then finally, next we're going to install all Node.js dependencies in package.json in the root of our project. So the first thing we want to do here is we want to copy over the package.json. Now, you might notice that down here I have an asterisk, a star. Yeah. The reason why is an asterisk is that allows us to have any suffix to package. For example, we could have package-test test, right? Or package lock.json is also another file that gets copied over. So any package with any suffix will get put into our working directory. So in this case, we're copying over both package.json and package lock.json. Package.json here. And so we're copying it over package.json from our host, which is our source directory, to this location in our working directory. So that would put package.json in our app directory.
Is the
because
host
that's
directory always where the file is located?
Yeah. So the host is where the file is. Exactly that. And then next it says to install the dependencies, not just copy over package.json, but now we have to actually install the dependencies. So
The question was, please,
the question here
is sets the working directory?
we set the working directory with work dir,
Install.
and now we're going to install all Node.js dependencies. So to install the dependencies, we already have package.json, which lists the dependencies and their versions that are applicable for our application. So next, we're going to run npm install. So we're going to say run with a big Dockerfile run command. All Dockerfile commands start with an all capital command, right? So here we're running, and we're going to run npm install, as well as any flags that might apply for when we're installing. For example, here I'm using legacy peer dependencies because I have some legacy dependencies in my application. So npm install, and this will install from our package.json. So this is our third step. This is our second. This is our first.
Question?
Yes.
Would it always be npm install, or is it just because you're using Node?
It's only because I'm using Node. That's just the Node command to install from our package.json.
Okay, if we already have the npm installed, still we have to put it out?
If you have, so you
Because
have
we can put it to npm and we mark, I'm talking about.
like if you have the
I have
Node
a
directory
very
in your like Node packages in your app.
Okay. Yeah, you did. Everything being, because it's very recommended. And that one, you have to npm already installed.
Yeah.
You have it there.
In your source.
Okay. Now, we have to put again run npm install, or she's already there.
Great question. So when we're creating Docker containers, when we're actually creating the content that's going to go into our image, there is such thing as a Docker ignore file. When what we use this Docker ignore file is we use it very similar to .git ignore, which tells us which directories we're ignoring and which files we're ignoring from including into our Docker container. Now, one of the most common things to find in our Docker ignore file directory is ignoring the package. What is it? The node packages directory. So it'll be node underscore packages or something along those lines. Wait, what is it?
Modules.
Modules. Yeah, that's it. It's node modules. Node modules directories stores the code that is all the libraries or all the downloadable content. Usually we put that in Docker ignore, so it doesn't automatically get uploaded to Docker. We usually install independently from our package.json to generate the node modules directory in our container so that we have consistency across environments, right? So because packages install differently sometimes for different architectures. For example, here in my Chromium installation, the Chromium package that I was using for Puppeteer, the Puppeteer package, was going to install differently if it was installed on Windows versus if it was installed on Mac OS. So when we're talking about installing our dependencies, usually we exclude our node modules that's in our source, meaning that it doesn't get included when we copy everything over to our Docker container, and then we install specifically for our containerized our image with npm install. Does that make sense? Yeah. And that's a fantastic question, because that's something that I would have totally forgotten to mention. And then finally, so here we're installing our dependencies. Finally, we want to copy all of the source code. This is just going to copy everything that's in our source directory that isn't ignored by .docker ignore. So to copy, we're going to copy all content, the entire period here, to, in our host, to, with another period here, all to our source, our working directory, right? That's why you see two periods. First one is all the content in our host and or our source file, and the second one is all of the working directory. Does that make sense? So target, source. And then finally here we want to run on port 8080. So we're going to expose internally 8080. And then we're going to run, right? Because it's saying run on port 8080, not just expose. So we're going to run. This is right here, step 4. This step is step 5. We're going to run. We can run either using the run command or we can use command here. Command is typically what we use when we're entering into our application and running persistently using npm start. So this is the parsed out command that we're giving it, which is just your Node.js start, right? So this would be step 5 here. Now, the interesting thing about exposing our application here is that imagine that this is our Docker engine, our runtime, right? And imagine we have a container here. Here's container 1, here's container 2. When we expose, we're not exactly exposing it externally, but we're exposing it inside of that Docker engine. So this means that if we use expose 8080 here, container 1 would be running on 8080. And if we expose 8000 here, that means container 2 would be running on 8000. Each one of these would have their own Docker files. So Docker file is native to the root of your project. So this is project 1, this is project 2. There's a Docker file for project 1 and a Docker file for project 2. The Docker file for project 1 says expose 8080. The Docker file for project 2 says expose 8000. And that's how you coordinate or how you actually program our containers to exist within an environment. Now, a question everybody might be asking is, how do we actually network in between these two, right? How do we connect them? How do we make microservices happen? And how do we make sure that, let's say we need two of these, how do we make sure that we can spin up 2 of them efficiently? And that's when we get into Docker Compose, Kubernetes, and Docker Swarm, and a lot of these orchestration services. So what Docker Compose is Docker Compose is a tool for defining and running multi-container Docker applications. So when you have an environment of microservices where you have multiple containers, you would use Docker Compose and be able to coordinate how these containers run together. You use a YAML file, or docker-compose.yaml, and you put that in the root of your directory. So it'll belong right in the root of your project, right next to your Docker file. Some key features of Docker Compose are simplifying and managing dependencies for multiple containers, as well as supporting volumes, which allow you to have persistent storage, networks, so networking between our containers, and setting up environment variables that span our project. You can automate container startup and shutdown with a single command. So instead of having to spin up each one of our containers with their own commands, you just use Docker Compose and it'll set up the whole system for you from top down. So it'll go ahead and set up each one of these containers without you having to run each one and spin each one up. It'll also scale if you give it scaling instructions so that you can spin up multiple of one container if you need to. So Docker Compose, the use cases are, if you're using a local development platform. So if you're just developing on your computer and you want to test a microservice environment, or if you want to manage application environments without needing a full orchestration platform, Docker Compose is like the baby of orchestration platforms, meaning that it's very limited, but it's really great for development. Its limitations are that it's limited to single host deployments. So you can't manage containers that are on different hosts, right? So say I had one Docker engine here and I had another Docker engine here with another container. Docker Compose is not going to be able to communicate between these two alone. You can use Docker Compose to communicate between all of these and this container and other containers on its engine, but you can't cross that gap. So that's where you reach a limitation. It also lacks some advanced features like auto-scaling or self-healing or load balancing, so controlling the traffic that comes in and out of your program and how many of those instances you need to spin up. So Docker Compose is super simple. It's a YAML file. YAML is just the cousin of JSON, so it's structured data and it's just a structured configuration file. So here you can see, as an example, we're setting up the version of Docker Compose that we're using. We're creating multiple services. So these are your containers that you're spinning up. One of them here is app. And in our app, we're using my app as the image. So my app is the image that we've already spun up in this case. And we are coordinating a volume that exists on our host. So remember that our Docker engine runs on our host. So here's our host, here's our engine, or our runtime, container runtime, and then here's our container, right? So in the case of volumes add persistent storage. So this would be storage. And when we set up our volume, what we're doing is we're setting up a connection between our container and our storage for being able to log data persistently. So if we were to destroy this container and spin up a new one, it still has the reference address of where our storage is located so that it can persist data. Because remember that containers are atomic. They exist and then they die, and then you create a new one from scratch, and then it dies, and so it's not going to hold persistent state. But in this way, you can hold persistent state by managing the storage on the host's machine. So down here, we're using volumes to declare a new volume called app data, or one that already exists. And here, we're binding our app data volume to our volume, which is named. So this gives me instructions for, hey, let's create an app with persistent storage. And the persistent storage is called app data. That persistent volume is managed by the engine. So it's not that the persistent storage, that the storage exists purely on the host. It's accessible on the host, from the host, but it's managed by the runtime in its own separate area. So Docker is going to create a volume here called app data, and it's going to self-manage it. It's going to find where to store that data on the computer efficiently, and then it's going to connect that volume to user source app data. So like we put all of our source code in our app directory, this is going to go into our app directory and put our accessible volume in the data directory. And so here's another example of a Docker Compose file. This one does not use volumes, but instead builds from scratch from the web directory. So instead of spinning up the container and having the container already existing and already spun up, already built, this one will build from scratch, versus this one will use an already built image, right? So two different concepts. Here, our volumes are already created and they aren't rebuilt. Here, we're rebuilding our image and we're rebuilding our container, and then we're connected, right? And here we're setting up exposing port 8080. So we exposed internally port 8080, and then we're connecting it to, oh well, this is the opposite actually. this is exposing port 8080 on the outside, so on the host, and it's connecting the exposed inside of the engine from port 3000. So what you would have is in your Docker file would expose port 3000, because that's your internal inside of your engine where your container is going to be connected to, is port 3000. Now, this all exists inside of the Docker engine, so in order to be able to access it from outside the Docker engine, you would expose port 8080 in this way here, when we're declaring port 8080 connects to port 3000. Does that make sense? So again, we have host and our container. And then here we're depending on another container, which is API, and that container exists within our services environment. So we're running out of time. We're not going to go through this technical problem, but this technical problem was just creating a Docker Compose file for a 2-service system, which exposed and mounted on an external volume for persistent storage. But in the long run, Docker Compose is super simple, very easy to understand, and very easy to use. Now, there's a lot more to this presentation, including container orchestration, how we manage our containers together and scale, and that gets into using Kubernetes, which is a service used for managing how you scale and generate your different Docker containers. I'm sorry that we're not going to have enough time to cover this, but we will cover it in another meeting. I definitely can see that happening. I think we're scheduled out right now to October, but maybe November. So without further ado, if y'all don't mind, please fill out your attendance. This gives us a ability to track how many people come to these meetings, what y'all like about the meetings, what y'all don't. Feel free to comment about any topics that y'all would like covered. We are going to end up having to skip the August meeting because it's going to be Fed Supernova over here, which is a conference that happens for federal and government employees. But we're going to have our next meeting in September, and that's going to be on agentic AI and as well as generative AI.
Code Foundry.
Code Foundry was our.
Come out with it, no?
Yeah, so this is yeah, that's all good. Code Foundry was a program we put on that was an actual boot camp for 12 weeks earlier on this year, and so it might say that, but it's all the same. So please fill out your attendance, and thank y'all. Please give feedback and let us know what you liked, what you didn't like, how we can improve. We want to best serve y'all. Does anybody have any questions?
Could you do this on online too? I mean, people can interact online, not
Yeah.
only just in physical person.
We were doing that when we were doing the boot camp. The issue with that is that it's hard to interact with a live audience and an online audience. So the best way you can find this video and you can review this content and watch maybe from home is that Capital Factory posts these videos and streams them live. So right now we're actually live on YouTube. So you can find it on YouTube. Yeah. So it's nice, you can do it from the comfort of your home, but we do like having y'all here. I like to get to see all of y'all's faces and interact with y'all. So let me know, does anybody else have any questions?
Just one, to make sure I got it right. So you said when you did the copy command with the 2 dots?
Yes.
The first dot was saying all the content in the host, and the second one was all the content in the working directory?
Yeah, so it's basically copying everything in the host just to that working directory folder, right? So the first thing is what do you want to copy, and the second one is where does it go?
Gotcha.
Yeah. Anything else?
Would the slides be available anywhere, or?
No, I usually don't publish them
Okay.
just because I want to encourage people showing up. Like we went over this pretty similar presentation during our boot camp a couple months ago. So yeah, no problem. But yeah, but the video is online and y'all will be able to see all of this on there as well. So I'll get there. All right.
What is online in the video?
It should be. It's on Austin Tech Live. If you look up Austin Tech Live here on YouTube, You can see it's actually streaming live right here. And it is Free Tech Bootcamp, Docker and Kubernetes, Microservices.
What do you call it? Austin Tech Live?
Yep, Austin Tech Live. If y'all parked, did anybody park in the garage? If you parked in the garage, I have parking vouchers right here. They cover discounted parking for the Omni's garage, but if you parked on the street, it's completely free.
I have a question regarding that package, Jason, which is
Yes.
where all your dependencies are, right?
Yes.
Do you manually create all the dependencies, or for example, I work with Spring Boot and Java,
Mhm.
you can have a POM file where all the dependencies are just there for you.
Yeah.
How do you get that package, Jason?
So this is just a node equivalent, very similar to like Spring Boot. Java is not my language. Don't get me wrong, but I think I have right here. This is an example. Is this package JSON just gives you the complete dependencies that you're using, the versions of each, and it's generated when you install a dependency into your development environment, right?
For Node.js?
Yes.
It's probably POM.
I'm pretty sure it's
Okay.
similar, and it works out. Also, Spring Boot can also be put in a image as well. So you can download a Spring Boot image specifically. Spring Boot is hard. I worked a job where they were doing everything in Java, and they were using Spring Boot, and it was a lot of adjusting. Yeah. I guess I'm just used to JavaScript far too much, and as well as like Django or Flask. So I feel like JavaScript's a little bit simpler.
What do you find hard about Spring Boot?
I just getting used to the Java language. I learned it in college, but it wasn't something I practiced.
So it's just programming language issue.
Yeah, that. And it also has, you know, the complexities of private versus public versus abstract and all the class level knowledge that.
Like object oriented?
Yeah, but also like Python's object oriented is way more transparent. Yeah.
¿Cómo se llama?
Gracias.
Grecia.
Gracias.
Sí.
Okay. ¿Y ahorita me da la educación?
Bye. Have a good night. Of course, of course.
Muchas gracias, Andrés. Muy bueno.
De nada, de nada. Gracias.
Una cosa que te iba a decir, mando CWD, de correo, siempre.
Sí,
Sí, ese debe ser el no se debe poner un ROM en lugar de CMD,
No,
porque ahí vas preparando la imagen. Al final ese que hace el launch. Sí.
Ah, sí, claro. Es que a veces me olvido de explicarlo, pero sí.
Lo otro que pueden hacer también decirme, cuando vayan a coger una imagen con un texto, que no copien de algo que sea real, no lo copien de alguien que hizo algo, porque puede haber una injection o algo.
In LinkedIn at all?
Sí, no, pero muy
Yeah,
bueno.
yeah. We'll see what you're up to.
Te voy a decir alguna
Or do you have
I don't know, it's
un
okay.
amigo y trabaja en una compañía hablando sobre ahorro.
Do you come to every meeting?
Una compañía
But you've been here before.
pero yo pensé en ti que me podía como tips a ellos.
Sí, claro, claro, claro que sí. O sea, a ver, sí.
Porque ella tú conoces el mercado y sabes cómo se mueve, y yo no tenía idea de qué cobrar ni nada. Andrés es la persona, right?
Sí, definitivamente. Me encantaría ayudar. El que aquí se puede encontrar el
Ramiro,
email,
Grecia,
el correo de
Ramiro.
me pueden mensajear. Yo recibo todo.
Pero ella se llama Carmen María.
Carmen María, ok.
Yo le voy a decir.
Oh.
Que te contacte para
So you just
Sí,
come
definitivamente.
Y la próxima reunión vas a enseñar cómo desarrollar rápido usando AI tools.
Eso sí.
Eso es, yo te lo voy a preguntar porque no haces eso.
Sí, sí, sí. Porque es bien importante.
Por ejemplo, para mí, yo pienso que si yo estoy hablando de hacer todo así, cosa base en la arquitectura, lo que tú dijiste ahí, que es súper importante, porque la gente cree que la inteligencia artificial es inteligente. Son algoritmos que hacen algo, la inteligencia es cómo usarla para lograr resultados.
Eso es lo que digo a mi hermana, ella cree que eso es Dios. El ChatGPT es así que sí.
Voy a estar mirando a ver cuándo lo vas a hacer.
Bye, Andrés.
¿Y qué vas a hacer?
I'll be right back. Oh, you're
¿Vas a hacer
the
algo
acronym.
como hacer una aplicación de React o algo así?
Okay.
Excelente, hermano.
But this is just like for,
For all young professionals, Latino.
okay. And just to like socialize, not.
No, they have 3 pillars, so one of them is, networking, the other one's, professional development.
Okay, let's get out of here, but we can continue talking about
Yeah, manage the close, right?
Yeah.
Marvin es lo que se usa en Java para dependencias.
Yeah, different.
Marvin se usa
We're
en
heading
Java
out.
para
We have this. Do
dependencias.
you want the voucher?
Maven.
Maven,
Oh,
eso es el
okay.
equivalente de Maven.
Okay.
¿Sí entiendes, sabes?
Sí.
Okay.
Gracias.
Hace mucho que no trabajo con Java, pero sé que Maven es
It's so nice seeing you.
importante.
Everything runs smoothly?
Yeah, everything went great. Thank you so much for everything.
Oh, yeah.
We're always happy to be here. Oh, there's another voucher, right?
Everybody get one? Get one?
Yeah.
These are like gold.
Yeah, they are. Magical.
Alright, we'll see you again.
Have a good night.
Yeah, you too. You mind closing this door behind you?
Yeah, definitely. Is there a way specifically to turn this off, or will it turn off? by
It
itself?
will eventually turn, yeah.
Cycle. Yeah. I gotcha. All right.
We'll get home safe, okay?
Thank you. You too.
Yeah.
It's closing time.